data that we make available on AWS. And then it's also interesting to hear what sort of data sets you're looking to use that we don't make available that might be helpful for your work. So those are sort of some of the things that I'm looking out for. And then if I see any sort of common issues that you all are running into, those are sorts of some of the things that I'm looking out for as well, to see if there's any way that we can sort of help you get unblocked there. So I'll stop there and just say I'm here the whole time, so feel free to use the chat box if you want to drop in any questions. And then Anna and I do have some other time at the end to sort of handle any sort of high level questions that come up, but I'll be monitoring the chat box as we go along if anyone has any questions they want to put in there as well. So I'll stop there, and Anna, did you want to say something?
Yes. Hi, everybody. Ana Pinheiro-Privet. I'm with the sustainability team at Amazon, and I lead the Sustainability Data Initiative, which is the umbrella program working with Joe and others at Amazon that basically is supporting this relationship and this cloud credit program. So just echoing what Joe is saying, this is a great opportunity for us to fully understand the extent of the work that you guys are doing, and just create an opportunity to help and identify roadblocks if there are any. From my point of view and ASTI, the program, we're also very interested in understanding how to better highlight your work and maybe make connections with other groups. So yeah, just reach out to us if you see opportunities for any of that. Okay, thank you. Thank you, Doug.
Great, thanks, Sana. Thanks, Joe. So from my side, most of you are probably familiar with GEO. Some of you may be not so familiar. So just a few words about what GEO is. GEO is a global partnership of governments and organizations that works to, whoops, I don't know, that happens periodically and I'm not sure why. I'm working off of Microsoft Office here, and it does some strange things. Anyway, the Group on Earth Observations is working in a non-binding best efforts way to open up access to Earth observations, and also to try to find ways to facilitate their usage with its among its member governments and participating organizations and the general public as well. And so this particular program falls within that scope. And in particular with this cloud credit program with Amazon, we were targeting countries who are in need of understanding Earth observation data that's available, and also have access to a data analytics platform, cloud services that can help analyze that big Earth observation data. And so that was the reason why we embarked on this particular endeavor. And in particular, Amazon was interested to support global policy, major global policy, for example, the Sendai Framework for Disaster Risk Reduction, the Paris Agreement, and/or the United Nations Sustainable Development Goals. So each of your projects was selected on its scientific merit and also on the extent to which it responded to support for each of these global policy issues. So one last thing, I'll ask all of you, I mean, I think we all have a lot of practice now using teleconferencing, but please put yourself on mute if you're not speaking, so that we can keep down the background noise and any potential echoes. And then also feel free to use the chat window if you have questions or comments. I'll be monitoring that, and we'll pick up anything that you would like to relay on to the group. So with that being said, let's go on to the first presentation, which is brought to us by INPE in Brazil, the Brazilian Space Agency. They're going to tell us about their Brazilian data cube and land use land cover classification.
Hi, everybody. My name is Karine Ferreira. I work at the National Institute for Space Research in Brazil. And here, together with my colleague, Gilberto Queiroz, I will present the results of our project called Brazilian Earth Observation Data Cubes using AWS for land use and cover change. In this project, we are working on 3 fronts. We are improving the deforestation alerts detection in Brazil by accessing up-to-date remote sense images from different sensors available on AWS. Besides that, we are producing multidimensional data cubes for Brazil from big data sets of Sentinel-2 images available on AWS, as you can see here in this picture. And we are also producing land use and code information for Brazil using machine learning methods and image time series extracted from these data cubes. Forest Monitor is a web GIS application used to identify deforestation alerts in Brazil using visual interpretation of remote sensing images. In this project, to increase the Forest Monitor access to remote sensing images from different sensors available on AWS, we developed a set of tile map services, as you can see here in this picture, using the AWS Lambda service. Using these services, Forest Monitor can access past and up-to-date images from AWS buckets that store Landsat 8, Sentinel-2, and Cibers 4, without needing to download these images and keep them in a local computer infrastructure here at INPE. In the Brazil Data Cube project, we are producing analysis-aware data in multidimensional data cubes for the whole Brazilian region. In this project, the volume of Sentinel-2 images that we have to process for all Brazil is around 700 terabytes. This is a big challenge for us because of the volume, the big volume of these data sets. So we developed an application called Data Cube Builder that runs on AWS using the Lambda service. And we are using this application to produce data cubes for Brazil using the Sentinel-2 images stored on AWS. In the end of this presentation, Gilberto will show a video of the first version of this application running on AWS. In the Brazil Data Cube project, we are also developing an R package called SEEDS that provides a set of methods to analyze image time series. So we are using the SEEDS R package running on AWS EC2 service to classify image time series extracted from data cubes and to produce land use and code information maps, as you can see here in this picture. So in this project, we are creating data sets for Brazil, analysis-aware data and data cubes on AWS that are very useful for researchers. Researchers, in this case, they need support to develop and test new methodologies to analyze and extract information from these data sets. So the big challenge for us is how to fund research with these data sets that we are producing on AWS. And as next steps, we will produce Sentinel-2 data cubes for the Cerrado biome in Brazil using the Data Cube Builder application. And we will produce land use and cover maps using the SEEDS R package running on AWS. In this project, we are producing useful data sets for research that study environment process using satellite image time series. And we are also developing useful open source software or technologies to create data cubes from satellite images on AWS that can be used for other people. Now we will see the video that shows the Data Cube Builder application running on AWS.
In this presentation, we will show you the Data Cube Builder application in action. As soon as the user accesses the application from his browser, The tool shows the existing data cubes which were generated by the platform in green, as well as the data products under construction highlighted in orange. Through this web interface, it is possible to monitor the activities being carried out, as well as those that have been scheduled for later execution during a data cube creation. Let's see an example on how to create a new Earth observation data cube based on a single tile that is a cell of 1 degree by 1.5 degrees with the same resolution of the data from the MSI sensor from the Sentinel-2 satellite. The creation of a new data cube starts with the definition of a regular grid, whose parameters can be defined by the user. Here, we will use an existing definition under the Brazilian territory. This grid, called BDC-SN, has the following shape. Let's go to the next step, which consists of selecting the region of interest over the defined grid and the input data source. The user can provide the address of a data catalog from which the data will be discovered and later accessed as indicated by the catalog. We will use a spatiotemporal asset catalog provided by element 84, which points Sentinel-2 data on the AWS. We will use the product level 2A and with images from 1st of January 2020 to 31st of December of the same year. The search button can be used to check the data availability and a summary of the number of images available to make the temporal composition for the selected region and period. In this case, more than 400 images. In this step, the user will inform the name of an AWS bucket where the generated data will be stored. He can create a new one or choose an existing one. Let's name this data cube Sentinel-2 DC. We will provide some more metadata that will be associated to the final product. We inform the details of the temporal composition for the product. In this case, a monthly aggregated. Then we indicate the best pixel selection strategy, the bands that will be used in the composition, and if necessary, we can indicate the creation of auxiliary spectral indices, such as NDV, NDVI, and EVI, and finally, the cloud mask band. We also give the possibility to define more metadata, the name of the satellite and the instrument. And in the last step, the tool presents a summary of the data cube definition. And after that, the user can start the build process. Let's see the details of a created data cube, in this case, S2 test. Here we can see the number of tests used to create the data cube and the amount of time spent on it, besides the images of each time step that can be checked.
Okay, I think that's we reached the end of the presentation. And I'm very sorry I forgot to introduce Karine and Gilberto. So let me do that quickly before we go on. So here is Karine's picture. Again, she's working at the Space Research Institute in Brazil, INPE, and she is the coordinator of this project. And then Gilberto, that we heard from in the second part of the presentation, is also working at INPE and is the coordinator of this project. So thank you very much for that interesting, very good presentation on the Brazil Data Cube and the facilities of land use, land cover detection. Do we have any questions for the group? Looks like Joe has a question.
Yeah, hey, so you're using a stack catalog as sort of the place to gather the metadata. I'm just interested to hear how critical is the presence of the stack metadata to allow you to do what you're trying to do? Put another way, if sort of stack did not exist or the stack metadata did not exist, would this sort of exercise be a whole lot harder?
Yes, we are, as you can see in the video, we are using the stack metadata to find the data sets, the images that in the buckets, in this case on AWS. And for, yes, Joy, I didn't understand the exactly your question about the stack.
Well, so if stack did not exist, or stack metadata did not exist, I'm just trying to get a sense of how important it is for the stack metadata to exist on these data sets.
Yes, in this case, yes, Gilberto.
I think that the main point for us is that the stack API, mainly for building machine-to-machine applications, it is very easy to handle the URLs and to work with the cog files. So it was the most simple part of our code deals with the stack, although we could also rewrite this part of the code to work with OpenSearch or another one. But I think that the stack is a very good facility regarding this idea of retrieving the items of a data set or an image collection. So
yes, and all these data sets that we are using on AWS, Cybersforce, Sentinel-2, and Landsat, these buckets are available with this stack catalog, and so and with cog files too. So we are using these. But as Gilberto said, you can customize the application to reach OpenSearch, for example. But in this case, now in this version of Data Cube Builder, they are based on stack catalog and service.
Great, thank you.
See, Michael Schultz, you have your hand up.
Thank you, Karine and Gilberto, for the nice presentation. It's great to see your work. In the past, I was working with INPE, and I don't know, maybe you know Tesio Novak, he's a colleague of mine who was also working with them. Anyway, so my question is, you guys were using Sentinel-2 data collection that were provided by Amazon, is that right?
Yes.
Which collection specifically did you use?
We are using the Synergize bucket, you see, and yes, we are using the Synergize because they are providing the reflectance, surface reflectance of Sentinel-2. So we are creating the data queues based on these surface reflectance analysis red data that they provide.
Okay,
Yeah.
to what extent were you satisfied with the pre-processing of the data? So I suppose you were screening your data in the first place. If they were cloud free, I guess these are like mosaic composites of something, right? Did you saw remnants of clouds, cloud shadow, or pieces of artifacts that were left? Because I'm always kind of on the chase of finding the best pre-processing for Sentinel-2 data. I'm just curious about your experiences.
Yes, in this process, to create the data cubes for Brazil, we are using this information, cloud and cloud shadow information, provided by these analyzed red data on the synergized bucket. And based on this information, we selected the best pixel in a month or in 16 days or what else. In the DataCube project, we are producing these two kinds, but as Gilberto showed in the video, you can choose another temporal compositing, 3 months or so. In this case, we select the best pixel in this temporal period, to create one image for that period that represents the best pixels selected in that period based on this information cloud and cloud shadow.
The synergized pre-processing algorithm, is that home built or did they import libraries from ESA? I don't know. Do you know that?
May I just add
Yes,
that in this case, we are relying on buckets that are processed with the CentOS software. So the cloud mask and the surface reflectance comes from the CentOS.
Okay.
If you are interested, Michael, please, you can reach us after the webinar. And we have people in the team that have analyzed the difference between using CentOS, Maya, the Lars RC, and other kind of pre-processings that we could apply to the images. So we would be very helpful. We would like to help you to proceed in the discussion.
Thank you, Gilberto and Karin. Thanks.
Thank you. I see we have one question from Yufu Liu.
Yes, the data cube from the chat. Does the data cube build support other satellite data source? Yes, if in this version of data cube application, if the data source on AWS has the stack catalog, yes, we can build the data cube from them. So if possible, I want to contribute to, yes, nice, very nice. We are very open to contributions and we can talk more about this. Very nice, thank you.
Okay, thank you. I'm sorry I didn't see the chat, the question in the chat window. So, but Karina, you got it. So thanks a lot. Okay, well, let's move on now to our next project. We're next going to hear from a project that is monitoring wetlands. And so here are the bio slides from the individuals involved. First, we have the project lead, Saeed Hamza from the University of Tehran. And they are looking at extracting semantic features for deep learning and Sentinel-1 and 2 data for land use classification to support geo-wetland monitoring. He has support from Ali Al-Nazrawi at the Babylon University in Iraq. And his role is to coordinate logistics and design the research. And then we have Michael Schultz, who is with us. I believe Michael is actually going to give the presentation. He is technical lead and is located at GI Science in Heidelberg, Germany. So with that being said, let's listen to their presentation.
Hello, everyone. So my name is Michael Schulz, and I'm presenting our work for the GEO-AWS work on behalf of Said Hamzeh and Ali Narawi at Babylon University. Our topic is the extraction of semantic features from OpenStreetMap using deep learning and Sentinel-1 and 2 data or Copernicus data for land use classification to support geo-wetland monitoring. Okay. So in essence, our problem is revolving around, as I mentioned, land use and land cover classification, and we are particularly interested in compositions of land use and land cover revolving around wetlands. So our study site, that's shown on the right-hand side with the red arrow, is directly at the border from Iran and Iraq, which is a small wetland, which is the Hura Lazim wetland. And if you zoom in at Google, you can see it very well. Or on the left-hand side, it's better, we have displayed two feature spaces, Sentinel-1 and Sentinel-2, which display this data. So what you can see quite well that actually when you have a look at the very left bottom image, the radar data that you see there, that this wetland is impacted by different usage characteristics, which is pretty distinct. So this line that you can see there, marked by these three red arrows, this is actually the border between Iran and Iraq. So you can see that the western side, they use it in a different way than in the eastern side. In fact, in the western side, more water, more soil moisture available than on the eastern side, on the Iranian side. So there are different regimes, different usage regimes. So and we're wondering how this is impacting the wetland, how we can make use of land use information available to describe the evolution of the wetland. So we're trying to do this with spatial descriptions, with descriptive statistics and with fragmentation statistics. All right, well, another key aspect that the Amazon Web Service allowed us to do is to test different models and data setups, which is essentially also the core of our work, right? So we are exposed here to a certain problem where we are essentially using different setups of feature spaces, different setups of models, and different training data. Okay, let's move on. So to show you the overview of our work. So we essentially we're using OpenStreetMap. If you don't know it, just Google it, because time is sharp here. And we extract waves of land use waves are just a representation of OpenStreetMap to describe polygons, to describe our study site, our wetland. And then we use this information to train our feature space, which is the Copernicus data, to classify those areas which are unknown, right? So the kind of like the catch or the key of our approach is that we're trying to produce a remote sensing classification, however, without injecting or training or without capturing any training data by ourselves. So we're using OpenStreetMap to take the training data, which some people already collected for us, volunteer mappers. We use the Copernicus data, also was collected for us. And then we just use GPUs, different types of models, to classify those. And that's kind of like the key spot or the sweet spot. Without the Amazon computing powers, we could not link those two things together. Okay, this is a bit our workflow. Okay, so that's you can see on the when you look at the right hand side to the figures, you can see some classifications results. So right away you can see on the right hand side the OpenStreetMap data as it is blank, right? Just as you see it when you have a look at it at that very side. And on the left hand side, our representation and our classification of this wetland, including land use areas, particularly anthropogenic areas, because those are of prime importance of us, they're shown there. So as I already identified earlier, for us it's important to understand the different usage policies and the changes of these wetlands, how this evolves over time. saw in our current activities, we were working with Sentinel-1 data and composites of Sentinel-1 data. Essentially, so we're using 5 bands, yeah, VV-min, VV-max, VH-min, VH-max, VV/VH constants, and also their residuals. And we essentially aggregated all Sentinel-1 scenes of 2019 and in some parts of 2020 with using a median max and certain other parameters to construct a very dense remote sensing, in this case, SAR, synthetic aperture radar information stack feature space. And the same thing we also did with an RGB data set, near infrared, for instance, short-wave infrared extended those RGB bands because those are available in 10 meters. Anyway, so these are the different feature spaces we were using, right? So we did our classification using just the radar data, just the Sentinel data. In both cases, pre-processing was particularly challenging for memory. If you have such a large area and you want to use all of the available Sentinel-1 and Sentinel-2 data, then you need a lot of RAM. And the cool thing was in Amazon Web Service, so we at the beginning for the pre-processing, we were booking, I think it was 0.5 terabyte of RAM instances to do the pre-processing, and then later we used GPU instances. So we could kind of like flexible switch from the different needs that our processing chain had by those solutions available by Amazon Web Service. So that was very useful for us. So then we tested different suitabilities of training data. So we just randomized our setup just in the way as we do it. And then one of the key things was comparing the different model performances, deep learning and machine learning suitabilities, robustness, and more random forest based, which is a more robust one, but pixel based. So one of the drawbacks with the deep learning was that it was kind of hard to optimize our the model, to reduce the loss functions. So here you see the different scores that we have achieved, and the training data that we used was rather noisy. This is kind of like the catch. That's a bit of the drawback. So when you use OpenStreetMap data, cool thing is you don't have to train yourself, but you have to live with what people produce for you. And as a result, since the mappers are very heterogeneous, right, you have high quality, low quality, different types of qualities available. And as a result, we were kind of turning our attention, should we tune the classifiers only, or should we tune the whole network? So classifiers, I mean, so we had 3 classes, urban classes, wetland classes, and other land uses. And then we also changed the amount of samples that were introduced. Usually with deep learning, you start off with more than 1,000 training sites. And this was a bit challenging in this area of interest because we just had few training sites available. So this is one of those areas where we have to either change the tag compositions which we use to extract training data from OpenStreetMap data, or in the worst case, collect training data by ourselves. But that's something that we want to avoid. So these are the different machine learning algorithms that we turned our attention to. Okay, just see the times. Up on time. Anyway, next steps, we want to vary optimization functions to deal with this noisy training data, vary the feature space for them, test different models, and include more training data, adding more text. Okay, anyway, looking very much forward to answer your questions. Thanks a lot. See you.
Great, thank you very much, Michael, and your colleagues, Said and Ali. Do we have any questions for Michael and their project on monitoring the wetland? What was the name of it again, straddling the border between Iraq and Iran?
The wetland. Actually, it would be a pleasure if Said would pronounce it. Huralazim wetland, that's how it's called. But if Said, he can pronounce it probably much better than I do.
Hello, everybody, and thank you very much for organizing this webinar. And thank you to you, Mikhail Schultz. Yes, exactly. It's a Huralazim wetland. It's a wetland between Iran and Iraq, and it's supplied by the water from the Iran and from the Iraq rivers. And it's a very, very important wetland in this area. And during the last years, actually, it was affected by lots of environmental disaster, including, droughts and other environmental and anthropogenic effects. And then it's very important to monitoring this wetland.
It looks like a very large wetland. Do you know what's the square square kilometer size?
I wouldn't know from the top. I had to calculate. I don't know.
Hi, Michael. I have a question too.
Okay. Yes. So Karine, go ahead, and then Joe.
Sorry, I don't put my hand here. Sorry.
Oh, okay.
Yeah, yes, Karine, please.
Okay, so
yes,
hi, Michael. Thank you for the presentation. I would look because you put something about training data in the end of the presentation. So I'd like to know more about how you are intending to collect more training data, because this is a big challenge. We know that this is a big challenge for us.
Thanks, Karine. So this is, I was hoping for that question. So, one of the key concepts that we are dealing with is that we don't collect the training data by ourselves. So the key idea of this research, and that's why this is a lot about method testing, is that we use OpenStreetMap data as training input. Okay, so this 8-minute presentation, it was tough to put things in there, so I did it rather quick. But so it works like this: we query certain tags that are related to land use, such as wetlands or agricultural areas, certain tags that can be associated with land use and cover classes from OpenStreetMap. Okay, you could see that in one slide. If you go on OpenStreetMap, you also see that these tags are existing. And then we take those tags and inject them in the feature space. And the challenge for us, that was something that I was trying to highlight, is to play with the right composition of those tags. Because usually, depending on the deep learning network that you use and the methodologies, you have to avoid noisy data. That's kind of like the key thing. So by avoiding collecting training data ourselves, because we query it directly from OpenStreetMap, we also inherit a lot of noise in the data. But that's exactly what we're trying to solve, and that's why we choose this test site. So yeah, if you want, you can go on this page here. Just
nice.
I send you something.
Thank you.
Just check this out, and there you see it's osmlanduse.org. A lot of the things we did in our research, we did on Europe. We were doing this, and now we're transferring these things in the Middle East region. So this was the idea, and this you could say the challenge of having enough training data is something that we overcome by using OpenStreetMap. Do you know OpenStreetMap, Corey?
Yes, I know. Okay. Yes. Very interesting. Thank you, Mike.
Check out the site. Might be nice. Yeah. Thanks.
I think Joe, you've got your hand raised.
Yeah. So my question was related to OSM as well. The type of mapping that you need to be done, can this be done by remote volunteers, or does this really need to be done by people with local context?
Yes, Joe. Thanks for the question. So you have different types. So I guess you're referring to OpenStreetMap in general, or to that project specifically?
Specifically for you, yeah.
In this project, there's too much noise that we get stable answers. So one thing that we are playing with is to inject also training data that we collected by ourselves. So what I see from our results, what I was trying to highlight with those slides where you saw where I was testing the whole network or the individual classes, is when we see these spikes up and down in your loss functions, that's a clear indication that your training data is too noisy. So I was hoping to avoid that. So we were hoping to avoid that. We were hoping to find intrinsic means of quality to reduce the training data or maybe complement the training data in OpenStreetMap, but without touching it ourselves. Right?
I see.
But apparently, to make our life easier, we might just go, let's say, for the solution. Okay, let's just collect a few polygons ourselves, just to give some good input and some good training data to the model. So this, something we wanted to avoid, but maybe it's a kind of like a crutch we have to deploy just to make results more stable.
Okay, yeah, so we can talk about this offline if it sounds interesting, but we do mapathons. Amazon does mapathons. We specifically edit OSM, and Amazon as a company also provides data to OSM for like our logistics people. They're not delivering packages in the wetlands, but like as a company, we also do like volunteer mapathons. So really my question is there some way that sort of non-local people sitting around the world can provide meaningful input to OSM that would be useful for you? So if that does sound like, if we got people together and wanted to update OSM, but they're sitting different places in the world, can we sort of edit OSM to help you?
They can, yes,
so
definitely.
If that sounds interesting, please reach out to me and we can talk about that.
It is definitely interesting, because one of the key things is that tags are often used inappropriately. So there's two challenges. One is to identify the right tags that qualify for that area of interest, that work with these targets, with these sites. Yeah, and then the second one is that the volunteers, that the volunteers are actually using the right tags. Local knowledge is always a good thing, but in this area, it's a bit of a remote area. It's a border region. You won't find much local contributions, original contributions. Most of the contributions at that study site, in fact, are by remote mappers. Therefore, in fact, this site could use a good chunk of, let's say, experienced OpenStreetMap mappers with their remote. That would definitely help us. So if you could facilitate mapathons for this area, that would not just advance this project, that would advance OpenStreetMap at large in general. Okay, in fact, cool. I just posted a link there. It's www.higit.org. We are doing lots of research with OpenStreetMap. And this was one of the application cases where we were trying to address, what do we do with challenging training data in an arid environment with wetland, where you have a lot of uncertainties. We're quite strong in areas, as you well know, where OpenStreetMap is abundant. But in those areas where we have a bit of scarce data and uncertain, that's why we were interested in pursuing this. And Ali and Said had this wetland idea, and that's why that was a perfect match.
Great, thank you.
Great, thanks. Thanks again, Michael, Ali, and Said. Very, very interesting project. Let's go ahead and move on now to our third project. This is going to be presented to us by Joseph Olukoi, who is the coordinator of this project on spatial agricultural intelligence uses with Earth observation data. He is affiliated with the African Regional Institute for Geospatial Information Science and Technology, AFRIGIST, in Nigeria. So without further ado, let's listen to Joseph tell us about his project.
Good afternoon, dear colleagues in the house. I am Dr. Joseph Olukoi, the coordinator of the projects titled Spatial and Agricultural Intelligence. The other members of the team are Mr. Adimusena, who is the head of ICT unit of AFRIGIST. AFRIGIST is African Regional Institute for Geospatial Information Science and Technology. We have Mr. Suma Momodu, who is the head of Photogrammetry and Remote Sensing Department, and Dr. Inusa Toko Muhammadu, a member of GIS department. As problem statements, we all know that to manage agricultural resources, we need up-to-date and accurate information on the condition of vegetation and crops, among others. And generally, in this part of the world, in Africa, and in our area of study, which is in Southwest Nigeria, such information generally lack, or if they exist, they are inadequate for proper monitoring of the agricultural system. So these information are necessary for precision farming. And we believe that remote sensing has the potential to provide accurate and timely information on which decisions can be based for economical development. The solution we are proposing through this project is to use a cloud computing platform and automated mapping approach to disseminate near real-time information to end users on the conditions of plants based on some biophysical parameters, and of course, information on crops. So far, since the acceptance of our project in June 2019, we created our AWS accounts and requested for credits, and this was granted and redeemed in October 2019. We requested them for 7,000 for the first year. Initially, we had some challenges in accessing these credits, and this was solved later after interacting with Joe Flasher in May 2020, who finally helped us to convert the credit to invoice. We have been able to create our EC2 dashboards, and we started a kind of familiarization with the AWS and the main platform that we are going to use for agricultural information, that is Send2 Agri. We, as updates, we are at the level of knowing better that platform Send2 Agri, because we discovered that it will take us some knowledge to be able to use it efficiently, and the collection of satellite data for land use extraction. We've been able to install the Send Agri 2 on our local server. We have started downloading some satellite images in on the area of study, as you can see it at the right of the screen. And we've been having some information also on the cloud-free composite of surface reflectance and statistics. Well, there are challenges and roadblocks because at the beginning, we underestimate the project, and we discovered later that our knowledge of AWS was very little, and also the use of the platform that we were targeting for the project, we needed some technical knowledge on it. So all this familiarization with these platforms took us some time. So finally, we've been able to get through with Send2 Agri platform, but not in the clouds. We install it on our local server, and now we need to migrate fully to the cloud, and this will need serious training and consultation. We have started consulting some people, and we hope we will get through. I would like to say that we could not use our credit of year one. We delayed in applying for the second year credit, and this attracted some invoice charges. We just received the year two credits with the help of Joe Flasher, and also after submitting a request case for forgiveness. The next step and expected impact: by the end of 2021, we hope to have moved fully the Send Agri 2 platform from our local server to the AWS cloud platform, and also the downloading and processing of satellite images for crop area identification, crop masking, the extraction of some relevant products. And also, we intend to go to the fields to do some checking, there some verification, and also, if possible, some data for calibration. When completed, the project is targeted to provide regular information. It's targeting rather to provide regular information on the biophysical vegetation status through physical indicators and some phenology indices. All this will be incorporated in the monitoring system for agricultural information. Thank you for listening.
Very good. Thank you. Thank you, Joseph, for that presentation. And we're very sorry that things kind of got off to a slow start, but it sounds like you're making good progress, and you know where it is that you need to go. So let's see. Do we have any comments? Let's see. I'm noticing here in the chat that Gilberto Camara, our director here at the Secretariat for GEO, has made some comments. Gilberto, maybe I could give you the floor if you would like to say what you have in mind.
Okay, thank you. Let me just get this Zoom. Okay, thank you very much. Can you hear me? I have a problem with my mic. So my point here is that some users have requested this version of Send2Agri in the cloud. And this is something that has come up in the first day. And I've been talking with the guys that support us on the Secretariat. Gilberto is also from Brazil. Gilberto Queiroz has been helping us on that. And we hope to have a version of Send2Agri as an Amazon virtual machine image soon. That probably will simplify matters for Afrigist and for others. Gilberto Queiroz, maybe you can jump in, please.
Yes, thank you, Gilberto. Right now we have one of the versions, I think that 202 or 201 of this image on the AWS stuff. This was a work that was done with the people from the University Católica of Louvain. It was a joint effort from the Secretariat with the Louvain team. So if you want to know more about this initiative to create this Amazon instance with Send2Agri, please, you can contact us also.
So Joseph, are you there?
Yes, Chris, I'm listening. I think this is a good news for us because the installation of Send2Agri has been very challenging. And with this new version, it will be very helpful for us. So we will contact Gilberto very soon, see how we can move forward with the project. Thank you.
Okay.
Great. Michael Schultz, your hand is up. Is that an old hand or is that a new hand? Maybe it's a hand from earlier in the session. So any other comments, questions for Joseph? One other thing I would also mention, Joseph, is I'm not sure if you're aware of GeoGlam, the geo-agricultural monitoring flagship, but I think it would be good to get in touch with Ian Jarvis, who is the coordinator. You can just contact me or contact, just give me a quick email and I can put you in touch with him. And I think he would also be able to help you with some of your issues. All right, then if there are no other questions, let's go ahead and go to the final presentation today.
Thank you.
Thanks again, Joseph.
Thank you. Thank you. We have noted all the comments, please.
Great. Okay, so our final presentation today is coming to us from the project being led by Rolando Vivanco Vincencio, who is at the National Program for the Conservation of Forests for Mitigation of Climate Change, the Ministry of the Environment in Peru. And he's looking at an automation of processes in the cloud for generation of mosaics of annual satellite images free of clouds to contribute to the generation of information on changes in forest cover. Now, as I mentioned at the outset, the presentation that we have, the video is in Spanish. So what I'm going to do is I'm going to show your slides, Rolando, and then ask you to give us the explanation in English, if that's okay with you.
Okay, Doctor.
Okay, so the floor is yours. Go ahead. Rolando, hello.
Hi. Yes, he's here. These processes of the automation of process in the cloud for the generation of mosaics annual satellite imaging free. But I want to explain about the title of the project. The methodology of the process is begin adjusted, but we tried one more year for this process. No? But currently we may use Sentinel imaging for to visualize changes in the forest and the main report. No, in this presentation and in this picture, we have a forest monitoring platform, GEO-AWS. This platform has a air alert submodule, so which information is generated approximately every 16 days with Landsat satellite image. It have been operating since 2017. We have 3,500 users. Each user have a rating of 5 areas. With this platform, the user select areas for monitoring. And the problem statement, the user register on the platform and choice or allowed their monitoring areas. No, the system periodical sends alerts are sent via email to users, and the user requires a report of the tile map with alert detect with Landsat. This report should have the Sentinel image in the background. This for visualization the chain. No? And this graphic is the process of the system. Mm-hmm. Next. Project status update. I have 2 processes. One process, we will Sentinel image for the Weaver. We need to be able to load Sentinel image and change the brains of the title are very there, and in Sentinel Hub. We need to integrate the Landsat image to view them as a web app service in the viewer. We need to insert the image in automatic reports. This is under construction. We need scheduling the generation of reports for using contain Sentinel Hub satellite image with AWS credits. No? In this image is the platform, and their reports. Next, challenges and roadblocks. We don't have programmers that dedicate to development. This is a problem. What we have, we do trust consultancy. We have programming the automatic reports, but we cannot insert Sentinel tiles in the background. Sentinel image look very dark. We need to develop programming capabilities AWS to integrate future solutions. Next. Next steps and expected impact, improve the use of Sentinel Hub mechanism for the GEO-AWS platform viewer, automate the generation of reports for using, integrate Sentinel Hub satellite demands AWS grade in order to allow them to see the change detected with Landsat. We need to generate approximately 40,000 reports per month.
Okay, thank you very much, Rolando. I realize it's a little bit difficult to present like on the spot like that, but you did a very good job. It looks like you're making good progress. Okay, now do we have any questions? So Shuhan Lu is asking if the early deforestation warnings include wildfire alerts.
No, in this moment, no include wildfires. No.
Okay. Because I think that's what Shuhan is working on in her project. She's working on wildfire early warning systems. Okay, anyone else? Elliot, please.
Just a thought, if you're considering putting alerts out, you could use the Common Alerting Protocol format for those. We do see uses, for example, in fishing, coral reef protection, even for invasive species. So if you're considering putting warnings out, you could use the Common Alerting Protocol format for that, which helps get them easily disseminated.
So Rolando could contact you for more information on that.
Yes, please. Common Alerting Protocol.
Very good. Any other questions or comments for Rolando? Okay, Shuhan just sent another message in the chat window that if you would like to consider wildfire, forest fire detection, that they would be happy to collaborate with you. So maybe that's something that you can pick up together offline after the webinar. Okay, Rolando, did you want to say something? Okay, if not, then let's spend just a few minutes. I'd like to ask Joe and Anna to give us maybe some feedback. Again, they've listened to your presentations. They've heard some of the challenges that you're facing. So I was just wondering if maybe Joe and Anna, you'd like to respond to those, or anything else that's on that caught your attention.
Yeah, sure, I can go first. So so again, very cool to see all this. This is actually very interesting for me, seeing, I guess this is our third day now. The first day, there's a very, like most of the people were using a very common tool set. And so it was easier to sort of come up with one key theme and sort of respond to that. But I think in the last 2 days, people are doing different things and using different tools. So it's a little bit harder. But I'll sort of give some of the same guidance. One thing that might be useful for you, for those of you who are doing sort of large scale processing, like batch bulk processing, is something called the spot market. So if you haven't looked for it, you can just search for spot AWS and you will find it. And it's basically a mechanism through which AWS auctions off unused capacity, compute capacity. And so you can basically get the same compute resources for a much lower price, something like 70 to 90% cheaper. The catch is that you don't necessarily get it right away. So if your workloads allow you to wait a little bit to basically run your processing, then you can potentially get it much cheaper. Obviously, we're covering the work right now with credits for you to prototype, but as you sort of move out of the prototyping phase and into more of a production phase, keeping your costs low is presumably of great interest. So I would definitely say check out the spot market if your sort of workloads allow for that. I think maybe the only other two things I want to say is a lot of you are using very similar sort of satellite imagery sources, Landsat, Sentinel. But if you're looking for other data sources, you should check out the registry of open data on AWS. I'll paste it in the chat room here. And there you can find all the data that's openly available on AWS that you can make use of. So we do have other data sets like OSM and things like that, other satellite imagery data sources, as well as other types of data sources that may be of interest. So check them out if you're looking for other data sources to use. And then as you're sort of learning to use different services, please do check out our training site. I'll copy another link in here. But you can find a lot of free training. There are also paid options, but you can find a lot of free training on how to use the various services. So I think a number of you are starting sort of with virtual machines, EC2 instances. That makes a lot of sense to start out with. But if you start to use more cloud native, newer technologies, and you're sort of trying to figure out how to make use of them, you can certainly check out the trainings. So yeah, I'll stop there. I mean, it's a little bit hard to find one common thing when everyone's doing different different workloads, but hopefully that's a bit helpful. And of course, I'm also happy to answer any other questions that come up.
Great, thank you, Joe. And just a bit on what Joe said, I definitely want to echo the excitement about the work you guys are doing and the opportunity to see it. And also on the training side, it came up in the previous sessions that there might be interest in getting additional guidance. We understand there's a lot of training sources for the AWS, which can be a little bit overwhelming. So we'll be looking into that, either kind of providing a little bit a narrow view of what are things that, or services or training modules that might be more relevant for the work that you guys are doing individually, or even try to set up maybe some additional sessions. The other thing is, for those that have not tracked, Doug and Geo had proposed the creation of a forum for us to continue the discussion among the different participants in this process. We haven't really taken off on that, but this might be an opportunity now that we all know each other and we know each other's faces and the work we are doing. It might be a good way and a good venue for us to continue the conversation and bring up lessons learned and pose questions to each other as well. So keep an eye on that. We'll probably revamp that. And just in general, just please reach out to us if you have any questions specifically about the work that you're doing now and how you might be able to grow it further. But also, as Joe was mentioning, as you think of the long-term sustainability of the work you're doing, if you want to continue post after the grant, it would be probably helpful for us to engage with you in some capacity to help you understand how to optimize the process, make sure that your costs stay as low as possible and you're getting the best service you can. So thank you again for all the time you guys have put into this and for making the time to come and showing it to us.
Great, thanks a lot, Joe. Thanks, Anna. So I'd like to open the floor now to anyone who has anything else they would like to add. Any questions or comments?
Doug?
Yes, Gilberto.
No, it's just to thank everybody for being here today and to presenting their work. It certainly was a very broad spectrum of things, but we're happy that you are doing progress in different areas, and that is very good for us. We have Peru, we have Brazil, we have Nigeria, or the Africans, and we have the Iraq, which is really positive. So thank you very much for being here today, and I think this is really important for us to reach out to such diverse communities. So it is my pleasure to welcome you all to the GEO community. Thank you so much, and may you continue well as you have been doing so far. Thank you so much.
Thanks, Gilberto. Yeah, it's very encouraging to see, you all come from the four corners of the world, and it's very interesting to see how you're managing to make use of this technology, use of big Earth observation data, and that's really that's the whole point of this program, is to allow you the access and the chance to do this. And so we're very pleased to see the progress that you're making. Maybe I could just, we have just a few minutes left. I'd like to maybe just ask each of the projects to tell us, we've heard some of the difficulties you had. Maybe you could just tell us what has been, the added value for you in participating in this program. How have you benefited from it? What is one aspect that you really like about the program? Just so that Joe and Anna can be encouraged to do more of these kinds of things with us in the future. Maybe I could, in the order in which we went, maybe I could ask Carini or Gilberto Queiroz if they would like to tell us what's been the benefit for you in participating in this program.
Yes. So I'd like to thank everybody for the workshop, the GEO and AWS. And so, Doug, I think that the open data, AWS open data is very, very important for us, this open data program, because we can use this data set there, Sentinel-2, and we will put our data sets there too. We registered for open data and we get this, so we will start to put our data sets there. And I would like to point out that this is very, very important for us that work with satellite images, because we are using a lot of buckets in this open data AWS. So thank you very much for that. And I'd like just to say that we have a little problem in the first year of the project, because we asked $10,000 to use in the first year, and we use more than 10,000. So we can't use the credit, the next year credit to cover this credit that we use more than 10. So for us, we have to use some project money to pay for this extra credit. So I would like just to point out this and say that I don't know if AWS can provide some, I don't know, when we get the money, when we get the top of the money, the AWS account stop works, something like that, because it's very hard for us, because we are trying a lot of scripts, a lot of services. So in some case we use a little more than. So I'd like to ask Joe about this. I'd like to ask if it's just a case that happened with us, or I'd like to ask Joe about this.
Doug, do you want me to wait until the end to address that, or do you want me to do it now?
Yeah, maybe we could just wrap up with that. Let me just go to the other projects, and then we'll take that one. Gilberto, you have a comment.
Yes, just one thing. I would like to say thank you to the initiative of this program. As Karine said, for us at INPE, it was very good for us to start to use the cloud services. We are very used with our local infrastructure. And I think that this initiative also accelerated a lot the things for us in the sense that we could get to engage more with the community that is working with the cloud services also. So for us, it was very good, and also because we also developed some capacity here now to work very well with not with the 100 web services from Amazon, but at least a dozen of these web services where we learned to use the Lambda model, the RDS services, and other stuffs that were very useful for us in the sense of the data cube creation. So I would like just to highlight that this was very, very welcome, this initiative from the GEO and the AWS in this sense. Thank you. And thank you for the invitation for the workshop.
Great. Thanks, Gilberto. Let's see, Michael or Saeed or Ali, would you like to just say a few words on how you feel you've benefited from the program? Yes, Ali, go ahead.
Yeah, I would thank you actually first, Douglas, and especially for Joe as well. Thank you, both of you. And yeah, we've been like doing a lot with the project and help us. For me personally, I built up a paper about like analyzing and monitoring the wetlands in south part of Iraq. And I wish to get it done soon and show you how we use that, as well as Said, I guess, and Michael. So it was really good opportunity for me to learn the basic of how to use it. Like I'm actually a bit at the beginning struggled to get to set up the things, but I mean I guess now I'm confident, like have like good level of confidence to set it up and use the deep learning things and the AWS, like GEO-AWS stuff.
Excellent.
So thank you for everything and for this meeting as well, and for letting us give us this opportunity actually.
Great. Thanks, Ali.
Thank you.
Michael, you want to say a few words?
Yeah, of course. I mean, I also like that. So one cool thing was we had, I remember, and it was a bit of a pity that, I mean, oh, sorry. You go ahead, guys.
That's okay. You can go ahead and finish your thought.
Yeah. So I don't know. I just don't know if that belongs here. Like I think it was in September or in October where we were struggling to get the funds for the next year. You remember this conversation? And then a lot of this collaboration faded out a bit. But in the first year we were quite productive, and we were trying to put putting out online webinars and workshops, and it was cool to have Ali here. Just see Zaid also connecting. In fact, I'm on the phone here. Yeah.
Great. Yeah. So yeah, we this is the first time that we've embarked on this kind of an endeavor together, and so we're learning as we go along too, and so it's good to learn what works and what needs to be improved. Maybe I could go to Joseph Olukoi. Could you maybe just say a few words on how you feel you've benefited from the program? I think you're on mute still, Joseph.
Yeah, I would like first of all to thank GEO and AWS for associating us to this initiative, for accepting our project. I would like to say that in honesty, this is our first experience in working using cloud services, and it's very exciting for us. In fact, it has given us opportunity to learn new things. And as a training institution, this has helped us also to introduce new things in our curriculum. Apart from just doing pure research, we are seeing that this is helping us to improve our training program. So my colleague, Sena, who is the head of ICT, is with us here. Craig, if you don't mind, I would allow him to say something, because he has been very much involved in what we are doing here in RPGs. Thank you.
Sure.
Hi, everyone.
Hello.
Hello. I hope I'm allowed to speak French on this forum. Bonjour.
Well,
sorry, I'll try with my little English there.
Try in English, because not
yeah.
French.
Well, Joseph have said it all. You know, as academic institution being exposed to new platform. You know, we are in Africa, and cloud technologies have not really entered the practice. So being exposed allow us to disseminate also and create the transition to reach students and all that. Yeah, I will not say that starting from scratch with the platform like Sentinel-2 Agric was a problem, because it allows us to really touch the configuration aspect and all that. And now I think we are not at the same level. What I would say about the sustainability of the program, because we also have to look into those things. We are working in Osun State, a very small place, and then how do we extend it to other regions and all that? Someone has mentioned the credit and all that aspect. So how do we make it sustainable to continue this work, this project, so that you really benefit to other parts of the country? So those are things I would like to mention and share with you. Thank you very much.
Great, thank you. Thank you very much, Amidou. Adimu, sorry, Adimu. All right, let's, Rolando, you're the last one. Do you have any final thoughts you'd like to give us on how you feel you've benefited from the program? Let's see, Rolando, is he still, yeah, you still there? Rolando?
Thanks, Douglas. I want to thank the opportunity to present what we are doing in Peru. We always need technology as a partner for the protection of the forest. Thank you for the opportunity.
Okay, thank you, Rolando. Okay, Joe, I'll give you the last word here.
Cool. Yeah, so I think there's 2 points here. So one is for the credits. So always please watch your credits, right? Technically speaking, so I have no power to get you money back if you go over your credits. So please always watch your credits. Some of you have run into this, but the year 1, year 2, year 3 construct, like we can work around that, right? And so really the reason why we did it that way was because credits only last for 1 year. And if you ask for them, even if you don't use them, they go away at the end of the year. So my worry was that, you know, if you were awarded a total of 20,000 credits and you ask for 20,000 credits in year 1 and then you don't use them, you no longer have any credits for year 2 and year 3. So that's why we sort of forced you to split them up into 1/3 or to make whatever request you wanted, right? And so it was really kind of to protect you. But if you know more exactly how much you're looking for, or if you make the year 1 request and you use all those credits in the first 7 months, please just reach out to me, right? Like we can work around this. So I don't want anyone to be stopped because they're still they still have the, like Doug would have sent you the initial email with how many credits you were sort of allotted initially. And so if you those are yours to use over the course of 3 years. So I guess that's the big point. But then Kainet, to your other point, AWS does not have a way to sort of shut off things when you reach a certain amount of usage, because it's not actually as simple as you might think it is. Because like storing data costs money. So do you want that data to be deleted, right? Do you want to stop your compute instances from running? Do you want, like there's all these services and they all behave differently, and it's not clear what you would want to happen when you reach a certain amount. So the sort of native AWS piece is that you can set up alerts. And so as you start to use a certain amount or get to a certain percentage of usage or forecasted usage, you can set up those alerts, and that best practice and information on how to do that was in the emails that I send when you sort of get your credits amount. So I would definitely recommend you to do that. But AWS doesn't have any way natively to just sort of say, okay, I used a certain amount, shut it all down, because it's really not clear what should happen there, right, to stop using it. There are third-party services that do this, but I think they are generally paid services and sort of outside of AWS and what would be covered by the credits. So yeah, I mean, I think we're right at about the time, so I won't sort of talk about that anymore. But yeah, I'm super happy to hear all the good things, and of course bummed to hear about the bad things. But hopefully we can work on correcting the bad things, and help you all do more of the good things.
Great, thanks, Joe. Anna, any final thoughts?
Just thank you very much. And as you said, Doug, this is kind of an experiment for us. So we know that some things are not optimal, and it really helps us to hear your feedback. So hopefully we can improve them in the future. Thank you.
Thank you. What I was thinking when I was sitting here is that we should do this again at the very, close to the end of the project, so like another year and a half from now. And I very much take the point that Adimu was making about, asking how can your projects be sustained, beyond the lifespan of these 3 years. So maybe when we do the next webinar, we'll focus on thoughts on how we could, develop sustainability for your projects. So that's just a thought that I had. Anyway, we're out of time, so thank you so much for participating. It's great to hear all of your projects, and we'll look forward to collaborating with you in the future. Have a good rest of the day. Bye-bye, everyone.
Thank you, everyone.
Okay, bye-bye.
Bye-bye.
Bye.
Bye-bye, everyone. Thank you.
Bye.
Bye.